phase rule equation was given by J. Willard Gibbs phase. The phase rule is a general relationship which describes connection between the number of degree of freedom, number of phases, and the number of components of a system. This relationship is expressed as F equal to C minus P plus 2, where F is the number of degree of freedom, C is the number of components, and P is the number of phases. Thermodynamic derivation of phase rule. The phase rule can be derived from the thermodynamic result that for a small change in a system at equilibrium, the free energy change is zero, since individual phase may contain two or more components in variable amounts. It is necessary to use partial molal free energy, that is chemical potential, denoted by mu, to make the treatment general. We know that dg equal to del G upon del T at constant pressure, mole fraction N1, N2, dt plus del G upon del P at constant temperature, mole fraction N1, N2, dP plus del G upon dN1 at constant temperature, pressure, mole fraction N2, dN, and so on. At constant temperature and pressure, dg equal to del G upon del N1 at constant temperature, pressure, mole fraction N2, dN1 plus del G upon del N2 at constant temperature, pressure, mole fraction N1, dN2, and so on. Since del G upon del Ni at constant temperature, pressure, mole fraction N1 equal to chemical potential mu I equal to molar free energy Gi bar, where Ni refers the number of moles of all components except the component I itself. Therefore, for C component, dg equal to chemical potential mu1 dN1 plus chemical potential mu2 dN2 plus so on plus mu C dNC at equilibrium, dg equal to 0, since summation mu I dNi equal to 0. Now we consider a system of two phases distinguished by symbol small a and small b in equilibrium at constant temperature and pressure. Then at equilibrium mu I component equal to mu I component B. This important conclusion can be generalized for any number of phases, that is chemical potential mu I component A equal to chemical potential mu I component B equal to chemical potential mu I component C equal to so on. If any phase containing C components, the composition is completely defined by C minus 1 concentration term. Since these are P phase, therefore P C minus 1 concentration term must be specified in order to define the composition completely. In addition to the composition, the temperature and pressure of the system, which are the same in all phases, must be known. Therefore, the total number of independent variables which must be specified is Pc-1 plus 2. The requirement that the chemical potential of any component is the same in all phases at equilibrium leads to the equation for C component in P phases. Therefore, chemical potential mu1 at component A equal to chemical potential mu1 at component B and chemical potential mu1 at phase P and so on. Chemical potential mu C at component A equal to chemical potential C component B and chemical potential mu C at phase P for each component in P phases. P-1 equation are known. Thus, for C component, C P-1 equation are known. Then, the number of unknown variable equal to Pc-1 plus 2 minus C P-1. Then, Pc minus P plus 2 minus Cp plus C, Cp Pc Cp जो है कैंसिल हो जाएगा, फिर C माइनस पी प्लस 2 या F इक्वल टू C माइनस पी प्लस 2 के लिए ये इक्वेशन है और ये थर्मोडायनेमिक्स डेरिवेशन ऑफ गिब्स फेज रूल को डेराइव कर दिया गया. वन कंपोनेंट सिस्टम, that is the water system. In case of a one component system, the phase rule equation becomes F equal to C minus P plus 2. F equal to कंपोनेंट की जगह पर वैल्यू हम रख देंगे 1, तो ये हो जाएगा 3 माइनस पी एफ प्लस पी डिग्री ऑफ फ्रीडम प्लस फेज इक्वल टू 3. That is the sum of number of degree of freedom and the number of phases is a one component system is always 3 when phase P equal to 1 and degree of freedom equal to 2. Thus, a one phase, one component system may be described by two variables such as temperature and pressure. When P equal to 2, then the degree of freedom F equal to 1, the system is called univariant. Similarly, when P equal to 3, then degree of freedom का मान 0 होगा, the system becomes invariant or zero variant or non-variant. The phase diagram of water system are as follows.